So I looked at your exams, and some were pretty good, and some were not, and some I never got. So for those students that still didn't have time to email it to me, the work, or send it to the wrong place or whatever, I emailed a reminder and I attached the midterm there again. So please make sure you check your student email. I know some people have tendency to check just about any kind of emails, but the only one that I have access to the student email. So please make sure you have access to your student email. As I said, it usually takes about 5 minutes to just pick up the phone, to dial the college, and to ask to connect with IT. And the IT will right away help you out with your password, access, and everything. So you just need to know your student ID number, and that's pretty straightforward. So please make sure you do that because you are taking an online class. It is your responsibility to make sure you have access to your email. That's the only way I can communicate with you. So it is very important that you do that. If not today, if you don't have 5 minutes today, I hope tomorrow or day after you'll find some time on the phone and call them, and that's all you need to do. Or if you're on campus, it's even easier. If you are on campus, just stop by the IT, they will help you right away. They will guide you. They get paid for it, so don't be afraid. Because I know it's more convenient for some people to use the private emails or some other things, but the student email is important because I email there everything. So please make sure you do that. So, anyways. Oh, you got it fixed. Great, great. I'm just saying that there's two more students that looks like never had any access to their emails. So it is in common problem. And I never punished my students for that. I give them time to fix it. It's important, not just for this class, for any class you're taking in our college. All right. Anyways, I'm glad that you are here, and I placed your grades on the Brightspace so you can check it out. If you can't, you can ask me. I will, of course, share it with you if you don't know how to get into Brightspace and stuff. Well, by now you should have. You should have really. And that's another question that you can ask IT if you still can't for whatever reason. It's better to go to some of these labs, and there are labs around the campus, and you can always get a free help. Because again, those people they get paid for it, so they're very nice, patient, and they will, of course, guide you. So please make sure you do that. So, anyways, I'm waiting. If you trying to submit me any work or midterm, I still have a couple of people that did not send it to me. Well, please send it to me. I will accept it, I will grade it, and I will put your grades on the Brightspace. That's why I think it's a good idea that I give time, not going to talk about that midterm. In fact, those people that did it, looks like they did it pretty well. I'm very impressed. That's the way to go. But again, if you want to redo it, well, just email it to me. I think I should be fair with the other students in class that already sent me work. If I'm accepting late work, so if they want to improve their grade, they can do the same test again and send it to me again by email. I have time, I can grade it again, no problem. But again, if the grade you got is fine with you, you're good. So we're gonna start another part of our class, the statistics part. You probably already noticed that class contains kind of unrelated topics, and that's how it's been designed. So, anyways, I emailed the link to this textbook to everyone. So my advice is that you can download it. So please try to download this. How to download it when you open the PDF. Here's the download. So just click download and it will drop to your device. And that way you will always have this textbook with you. It's not going to expire. And that's a good thing about having the copy of the textbook. So it's totally free. It's standard textbook in statistics. It's written by Mario Triola. So if you already took statistics course, we're just gonna do the same thing pretty much till the end of semester, and I hope we'll enjoy it together. So anyways, I'll be selective with topics, and chapter one, which is called Introduction, is just introduces people to statistics subject matter. So I'm gonna not to worry about it. I'm gonna move to section 2 of chapter 2. It turns out if I go to 2.1 on page 38, and if I put 38, of course, it's not going to show me 38 because it's going to give me previous section. It's 26. So 38, I needed to add 12 to get there. So I need to get not 38, but like 50 and to get to page 38. I go 50 and we're, well, a little bit skipped over. So anyways, I can return back. Because when you deal with this kind of online textbooks, it's easier instead of just scrolling up or down, is just to put the page number here on the side, and that way you will be able to get to see the page you need much faster, much faster. So at about 10 or 12, something like that. So anyways, we gonna notice that on the actual page I was trying to get right away, page 38, there is a beginning of story, and the beginning of story is just the introductory pair of paragraphs that discusses statistics in general, and that's what we're gonna actually see in section 2.2. So what they discuss is so-called distributions. Distributions is a special statistical term. So statistics has its own terminology. And distribution is nothing else but the table that contains all the information. Like on the picture on this table 2.2, and here we dealing with the information on so-called 5 classes. So there are 5 classes here. 1, 2, 3, 4, and 5. I can try to make a little bit of graphing presentation here. So if I take a segment and cut it into 5 pieces that start at 0 and run all the way to 499 to describe my 5 classes, so I can, for convenience, make this a little bit longer and have a wiggly horizontal bar here, because 0 is in the beginning, but what's in here? Well, for convenience, I just move it a little bit away, this not Y, but so-called frequency axis. And this axis will discuss my classes. So axis for the classes, class boundaries we have here. And these 5 classes that start at 0, then 100, 300, 200, etc., we have on the horizontal axis. So I broke it into 5 equal classes, and the distribution they gave us here shows how many elements or so-called frequencies, that again related to showing me number of elements in each class. And the largest of these frequencies I see here is 14. That's the highest value that corresponds to class 3. I put it on top so everything will nicely fit into my picture. So for the first class, I have a height 11, and what I'm going to do is produce the bar with that height of 11. With respect to 14, it's a little bit shorter. Next is higher, so it's about 12. It is actually equal to 12, so it's a little bit higher. That's the bar that will correspond to the next class. Then my largest, the tallest bar will be of the height of 14, okay? And then the smallest one with a height of just 1 in here. So that's very little one. And then next to it will be the one that is twice taller, the last one, which is of the height 2. So what I produced is called histogram. That's another statistical word that you will see again. And one may say, Alex, maybe it's just a bunch of bars or bar graph. Yeah, you can call it like that as well. So I'm not making you memorize this terminology, but just to be familiar with it. And that's exactly what that section 2.1 is discussing. So those names, terminology, and statistics, which is a little different. Let me say, what if I use it my own description? Well, I will understand it, so I'm not gonna pick on you because I know probably in like what's left? 8 more weeks after the end of semester, you probably will forget the statistical terminology if you're never gonna use it again. But I would highly recommend you to take statistics class. I believe it's Math 125 after this because you'll be very good at statistics. So you will, of course, learn more, but we're going to look at the beginning of statistics story. That's how the course is designed. For those people that will never take any statistics, but it is turns out to be very useful part of mathematics in the real life. So anyways, histogram. If you already took statistics, well, you will feel very comfortable and I hope will enjoy refreshing your memories on some things. Now, I'm not gonna be discussing everything in this textbook in the first chapters in very detail, just something that we need to summarize the story for this class. So anyways, statistical name histogram and the name of frequency that deals with number of elements in each class, and the classes they put here catenin, whatever it means. Well, they probably should have put just classes. They say it's catenin levels. It's cigarettes probably. But anyways, the presenting of sample, that's another statistical word, sample, and that's very important word. We're going to hear it every day when we deal with statistics. And the size of that sample is total number of so-called frequencies. In other words, if I go ahead and add all of these frequencies together, I'm going to get 40, looks like, which means that in a sample, we considering, let me say what sample we consider. I don't see any sample here. Yeah, somebody done all work for us. That was nice. They done all work, so they collected 40 pieces of data, 40 elements that are not shown in here, but they grouped them into 5 classes, and they saw that the most popular were first 3 classes. So most cigarettes contain that much of catenin, and the rest, well, we can probably disregard. They're not popular, don't appear. So if you go and buy cigarettes, then you can rely on getting up to 300 units of that stuff, catenin, whatever this means. So then you can start a related study. So the point of story, now we probably have much better feeling of what is going on compared to just looking at all these numbers and wondering what are these for and what is going on. So giving people a picture gives a better intuition. And that's what you, as statistician, doing. You're trying to present data collected to someone who has no clue what is going on. So they just get better idea by getting nice intuitive pictures. So that's one thing that appear sometimes in the business newspapers. You probably saw various graphs, and I will take a look now at another table. And that second table is related to so-called relative frequencies. Maybe I better return back and copy my first table so we can compare them. So what I can do is just write down the class and then frequencies or number of elements that appear in that particular class, frequency. And we had 11, 12, 14. So the book of Mario Triola, the one that I'm using, is written by Mario Triola. Had so many editions already. It's a very popular textbook because Mario Triola collected correct samples. So he did not make them up. He spent tremendous work. He had access to real data and he just utilized actual samples. And that's why it's so popular. So it's not just me as Alex sitting down and trying to imagine a bunch of numbers. And that turns out does not really work well. But if you get the actual data, that's definitely very interesting and applicable. So here's my table. I copy it in the meantime, and then I'm gonna extend it to one more step like the next table does. It's producing so-called relative frequencies. Relative frequencies. And those are produced by dividing. So if you have total of 40 elements, the sample size, then you're going to divide each of this frequency by 40, by the total. So if I go ahead and divide first by 40, and then next by 40, so I divide all of these frequencies by 40. That way I will produce so-called percentages, and that's what they actually have here on the next table. So they divide it by 40 by the total, and that enables you to see what percent of the whole thing each of these classes is actually taking. And that's what they have in the next table. We can verify it. So you can see that first is 28%. So what I can do is get a calculator. Free calculator is called scientific calculator. I think I already used it once. Scientific calculator. Start typing it and it appears. So in Google, it's a choice one. I'm using Google as a search engine. So choice one utilizes probably the best calculator that I encountered because it's free, but not just because of that. It's calculator for statistics that shows us everything we are doing. So if you are not doing something right away you can see it if you double check. So first fraction is equal to 275 thousandths, and that way they call this approximately as 28% or 0.28. Please notice that number of percent is number of hundreds. And when you're looking for the number of hundreds or number of percent, you round it to the nearest. And since 7 is followed by 5, then you add 1 and you get 8. So 28%. So that's what's in here. So notice we made it a little bit larger, this number, right? But anyways, analogously, we can produce those percentiles for every of these entry in the table for 12, for 14, and then for number 1, divided by 40, and finally for number 2. So this way to divide, let's see, in the center right away, I can see divided by 40. And let me write down the actual decimals and see what happened, how they round them. So 0.3, well, that's 30%. It's exactly 30%. Next is 35%, looks like, right? 0.35. So no need to round. You see 0.3, they put 0.30. Yeah, 0.30, same as 0.3. Next is 0.25. To get to percents, I need to also add a little bit to the number, right? So approximately trying to put this wiggly equal sign is 0.03, right? 3%. Okay, and finally, for the last, I get a 5% exact. So that's what my table actually shows in here. So you can see that's 3%, 5%, so you don't need 2.5%. Even though you technically could have it to get more exact, because now when you're gonna add those percentiles, looks like you're gonna get not 100%, but 101%. Right? And one is there wondering how come it's 101%? Well, because we round it. That's absolutely fine. And as long as it's off by 1 or maybe 2%, it's okay from 100, because the whole thing must be 100%, and I can split now my whole thing into these 5 classes a little bit differently. Like the first is 28%. So a quarter is a little less, so I put someplace here. Trying to do my best to get as close as possible for my class number 1, which is 0 through 99. So I present my sample, remember word, sample with a so-called pie chart. That's another statistical word, pie chart. Well, I present it just like that with pieces like pizza we cut into slices. So next is a little bit bigger piece, it's about 30%, right? Let's see, Alex, it's exactly 30. Okay. So second class that goes 100 through 199. So this is my second slice of that pizza or in that pie that we have, and that's great. And next is the largest, 35%. So the largest needs to leave me with only 2 little pieces. So one is going to be just 1% and the other is 2. So just break into 3 pieces and take 1. And the remaining, the last. So 200 through 299, the largest slice, right? And then we have 2 more. One of them is here, which is 300 through 399. And finally, the last one goes from 400. So 400. 499. So I just presented exactly the same data, but a little bit differently with a pie chart. Well, why is that? Well, I can't say, but sometimes you probably a little bit familiar with business sections and the newspapers or various magazines, and they like to present data as chunks of the whole thing. So the pie chart is one of this other type of representation of the sample of the same exact sample. And well, I guess that's great to know. So we present in data here. That's what we're doing. And they actually discuss all that in the section 2.2. So you can see various tables or distributions, right? And in the next section, they actually talk about this histogram way to present data. Okay, so histogram or by bar graphs. So it looks like I discussed the same story that overlaps from section to section, and that's what happens in the beginning. In chapter 2 sections, they have common ideas, and one sample I can use to describe various things. For example, the next part of the story, which is called ogive. That's an interesting word, right? Ogive. So we can justify the producing the ogive by extending our table a little further to so-called cumulative frequencies. Cumulative frequencies, which means accumulate or add the frequencies together. Notice that this ogive just keeps going up, so you just keep on adding. So you take the first frequency 11. So I'm just looking at my column with frequencies. 11, and then I add it with 12. So when I add 11, 12, it becomes 23, isn't it? So just keep on adding the next, and then the next, and the next, and then eventually I'll get the whole thing, which is going to be 40 at the end. Let's check it out. If I add 14 to the previous, it will become 37, right? Okay, so it is. I need to now increase it by 1. And if I add 1, it'd be 38. Right? Okay, 38. And finally, the last one, which is 2, when I put on the top of 38, it'll be 40. So cumulative frequencies, and that way we can produce that so-called ogive, the graph of cumulative frequency distribution, by, again, taking the horizontal axis with our 5 classes to start. So this is again 0, and then all the hundreds, right? 100, 200, and etc. 3 and 4. I'm so glad I was able to clean all this cache memory of Zoom programs and recordings that I had since the year 2000. It's 2020, right? That's when we had COVID started. That's when we started to use Zoom, actually. And the college was shut down for a while. And I accumulated already like 600 various things there. So just cleared all that, and now it started to work, and I'm so happy. So now I can accumulate more for the next few years. How about that? More recording. So I need to put the largest number here so it fits nicely. And the largest number is 40. So that's the one that I have among those frequencies. 40 is on the top. And now I start with the first, which is just 11. So it's about a quarter. So please notice, to end this whole thing, I need to go here at the very end, 499 or 500, whatever you like. By 1 is making not much difference. So if I look at the first entry, which is 11, then it will be someplace here at the end of my class. That's the idea, because the last one is at the end of the sample, so I put these points at the end. So now I need to about double it to get to 23. So that'd be my next point here, at the end of class number 2. Then at the end of next class, it'd be 37. Right? 37. So here. And then just a tiny little bit higher for the class before last. So I'm trying again to do my best to get it as close as possible to reality. And then we connect with straight line segments, these points, and we produce that ogive. And we need to start it on the x-axis where our sample starts, which starts at 0. And that's exactly analogous graph to what they have here in the picture on China. Again, it presents data. We say, what is this really needed for, Alex? How do we present it? Well, you can, for example, ask someone, what's the level of cotton in between 200 and 300, 250? How many brands of cigarettes probably have that level of cotton? 250. So you could imagine yourself the corresponding point. It will be somewhere between 23 and 37, so probably about what, 30 or something. Again, it's approximately. And again, it's being utilized for big samples, like 500, 600 samples. But I would say about 30 brand out of 40, total is 40, have such a low level of cadmium. So just can utilize this for further estimates. So that's the start of the statistics story. And please notice, this is really not a mathematics, right? Statistics is statistics. So if someone is really scared of math, I'm sure you're gonna like statistics much better because, well, there we have lots of descriptions and things, and I'm trying to give you main points here again, because there are various graphs, such as a frequency polygon that you could produce connecting central points of each of these bars together. So that will be something we have, but I don't think we really need, I don't think you're really utilizing it anywhere. So some stuff I'm gonna skip. Like interesting one is stem and leaf plot, but I need another sample to be able to do it. So we'll probably need to utilize another sample, another totally different sample. So you can see this pie chart. So it is again popular type of results, but sometimes you gonna see graphs like we have here and we say, what is this? Well, don't bother with this. There are time series and Pareto charts that, well, I don't think you see it anywhere but in this textbook. But if you go ahead and move on a little farther, I'm trying to get a sample again to go over the same ideas again. And I think it'd be a good one in exercise 34 that I can actually work with. There are actually two samples in exercise 34. I will use one because it's one and then there is another. So I don't want to use it twice, do the process twice. I'll just do it once. But I think it's a good idea that we take a look at one of these samples. Let's say first one that deals with actors, they say, and the year when they got their Oscar award. So we can try to figure out exactly the same stuff once again for those popular actors. And then if you feel like it, you can do the same thing for actresses if you're interested. And if not, you can just copy one for actors and then be your homework for next part of the class. So anyways, let me try to clean this mess and I will do it real quickly by stop sharing it. And then I share it again. So I can do this. So actors and actresses, how can I start working and producing that histogram or all the frequency distributions related to the sample? Well, it turns out that first of all, I need to find the smallest and the largest numbers here. I see 31, that's my starting point for the sample. And And then I also see the largest, which seem to be 76. That's right. 76, I think, is the largest number. Please correct me if I'm wrong. So now I need to decide how many classes I have to utilize. And I will always use 4 classes. That's the lowest number of classes I can utilize. 4, they say less than 4 makes no sense. 4 is the lowest. You say, Alex, why not 5? Well, I know that the less you use, the better. But if you like 5, you like 10, use 10. But please notice that the sample size, we have, remember, it's n number of elements in the sample, is going to be 2, 4, 6, 8, 10, 12 times 3 is 36, and 3 is 39. So if you have 39 element sample, then it doesn't really make sense to use number close to 39 as number of those classes, because you just have 1 element in each class is kind of pointless. So 4 classes, I would say, is good enough. So if I take a sample range, which is from 76 to 31, and break it into 4 classes, break this into 4 classes, what I'm going to get, each class width, how wide is each class, and that way I will be able to produce those boundaries for my classes. So class width. So it looks like, for that matter, I could utilize calculator.
9.
So let me make sure I do it right. No, don't
I
hurry.
think it's 9.
Yeah, you could reduce that. So if I put 76, so if I use my favorite calculator, and if I subtract 31 from it, right, and divide this by 4, I get some kind of number, whatever, it doesn't matter. But the point is, you got a good idea. Make sure that you don't put those decimals, because when you put decimals, you're gonna confuse lots of people. So I would say approximately there's 11, the whole number. So if width of each of your class will be about 11, whatever, then
Professor?
Mhm. Yeah.
Hello?
Yes,
Yeah,
yes.
if we subtract first the 76 minus 31 is 45, and if we divide it then by 4,
Mhm.
it's 9.
45, right?
Yes.
Yeah, I use a calculator. It's 11. 4 times 11 is 44, and 1 over 4 is 25. See, that's why I'm advising to use a calculator. You're doing pretty good, but you might get like a little misprint. So that way you will get the actual whatever it is. So,
Mm.
so it doesn't matter. Don't worry. So we'll just put whatever we produced. Please notice, because I rounded it, I will get something that is going to be not really, well, maybe we meant 5 classes. If it's 5 classes, then it'd be 9 yet. But anyways, it's not going to be exact. We're trying to make numbers better. So if I add 11 with 31, I get 42. Right? And if I add another 11, it'll be 53. And if I do this again, it will be 64. But if I add again 11 with 64, it'd be 75. One can say, Alex, this class is wider. Yes, one class could be wider or a little narrower, but you're paying that to get better numbers for your classes. So when you start to produce your distribution, so if you start to look at your classes, you will get better numbers than the ones with these decimals. Because
some people might see decimals and they say, Alex, this is so confusing. I don't want to see this ever again in my life. And they will panic and don't really care for your further explanations. But when I put this nicer looking starting points for the classes and end it at 76, right? Well, that will feel a little bit better, I hope. So anyways, next is gonna end where? 64, so we need to end at 63 to make sure the classes do not overlap. You see, the classes need not to touch each other. People say do not overlap, so this one will end at 52. So the next will start at 53. And the next at 41, right? 41, and then it's 42. So classes and the frequencies. So what about number of elements in each class? Let's find out. I need to go back to my sample and just count how many we have. Where's the book? Here's. So first class goes out to 41. So how many elements? 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 12. 41 is in the first class, 12, 13, 14, 15, 16. Please let me know if I did it right. If there's 16 or not really. So Alex, what if I missed something? Well, don't worry. I'll show you what to do, how to fix it later. So anyways, I'm breaking it into 4 non-overlapping classes. So I just got elements of the first class. 16 of them. See, that's how the frequency is being produced. So analogously, I'll go for the next class up to 52. So that'd be 1, 2, 3, not as popular, huh? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, there's lots of elements here as well. 14 elements for the next class. Okay, whatever, just take it easy, just write numbers and move on to the next. Next is 53 through 63. So the class before last, what do we have left with? So 1, 2, 3, 4, 5, 6, 7, 8. Pretty much everything that's left. 8, right? Okay, 8. And for the very last class, we have only 1 element left. Now, is that right? Is our sample equal to 39 elements or not? Important moment. 30 when I add first 2 classes, and 9 is exactly 39. So this one I got really lucky. Because sometimes, yes, you start to produce your frequencies and mess up and forget 1 element or add an extra one, whatever, and you don't get 39, you get something else. So you have to redo the whole thing, which is not good, but it's okay if you have plenty of time. In fact, you probably noticed that on the tests, I have a tendency to give plenty of time and even more than time than one needs. So that way everybody in class feels comfort, right? That's the goal. Because I know this kind of procedure, it is indeed kind of tricky, right, to select the elements. I've been doing it so many times already, so I kind of get used to it. But anyways, after the frequencies, we can produce our histogram, remember? Histogram, so I break this into 4 classes now. My sample will consist of 4 classes. It should be straight line, of course. So the classes start at where? 31, right? And then we'll go I put beginning points of each class to be consistent. 42, 53, 64, right? And the very, very last that ends at 76. Okay. Great. So on the other axis, please notice I put a little wiggle here. That's standard in statistics. So I don't care where zero is, here or further. We just want to make sure the picture nicely fits into what we really need to describe. So the tallest is 16. That'd be my upper point. And that's actually the height of my first bar that presents my first class. And that's great. I have it here. So with respect to it, I'll get a little lower bar for the second class height 40. Good. We have a good start. Now we continue with next height 8. Notice that it's half of 16, right? So, and then finally, the very last class that is height 1, one may kind of wonder, is it really needed here? Because there's only one element in the last class, so probably it takes us away from what's going on in reality. So it looks like most people that get their Oscars are in the first two, but there is a third category as well. Frequencies, and a histogram that deals with those frequencies. What else? Remember, we were also producing relative frequencies or percentages for each of this class. So relative frequencies that we produce by dividing frequencies by total, which is 39. Okay, so let me divide each of them by 39, right? And then I'm going to go ahead and round to the nearest hundreds. Number of percent is number of hundreds. So that's what I'm going to do. Each of these divide by hundreds. So calculator time. Free calculator. If you have your own calculator already, use it. If you feel comfortable using some other tools, I always say to my students, use whatever you prefer. Because again, your way of doing this procedures is always the best. So let me divide each of them by 39, each frequency. And please notice it doesn't take too long because I did not end up with so many classes. It's just the less classes, the better, I would say. But again, 4 is the lowest. Anyways, there we have it. We have everything we needed. And I'll just try to round them when I put them down to the nearest hundreds. Why hundreds? Well, because we want to get percent. So this is about, I put this wiggly, means approximately equal to 41%. Right? Why 41? Because followed by 0. Well, that one will be 36 because it's followed by number bigger than 5. So it's 36. Okay, just 2 more. The next is 21% approximately, right? 0.21, 21%. The last one is 3%, right? Because again, it's followed by 5. Please notice we rounded them all up, all 3 of them, right? So probably again, I will get the number bigger than what I need, means more than 100%. Notice 1, 6 is 7, 8, and 3 is 11. So when I carry 1, it will give us 5, 8, and 2, which is 10. So put 1.0. So 101%. Well, we already saw that's okay because we had this already in the previous case as well, right? In the previous example in the text. So 1% bigger, or maybe 1% smaller if you rounded them to the lower. It's fine. So relative frequencies for my pie chart, right? So this was called histogram, right? Histogram, bar graph is here. And now I'm gonna get the pie chart. Pie chart. It's like a pie. I already feel like having a lunch. Yeah, after this, you can probably enjoy a lunch. You will have well-deserved lunch. You can slice into get a pizza and slice. Say, tell them not to slice it. I will slice it myself. Guess who's gonna get the biggest slice then, right? So you'll deserve it. So it looks like if we got quarters for convenience, I will now try to get those percentages. So 41%, the first one, 41%. I go with more than a half. In fact, more than one slice is about that much, right? That's actually my largest class. It's 31 through 41. Okay, that's the first one. Next, we have another big one, 76. So please notice that together they total to about 77%. So it's more than a 3/4, right? A little bit more than 3/4. 75% is 3/4. It's more than 3/4. So this is class number 242 through 52. Okay. 2 more classes only. So one of them is 8 and the other 21%, the other is only 3%. So 5363, that's one. And finally, the very last one is 64 through 76. So that's our pie chart. And looks like, again, the last class is least popular. Right? Okay. Let me do an ogive for you real quick and let you go and have a lunch. You, I know, deserve to relax a little bit. So I'm gonna need to find the cumulative frequencies, right? The last thing we do is find the cumulative frequencies, and we need to add the frequencies. So first I copy the way it is, 16. Let's see. And then I need to start adding the previous frequencies to the one I have here. So I have here 14 and add it with 16. And that will be 30. To the next one. And then we'll take that 30 and again increase it by what we have in the third class, which is 8. So this will be 38. Okay, 38 is here. And finally, 38 I will add with 1. Okay, so this will be 39. And again, I just saw that my sample size 39 is exactly the last cumulative frequency, and that's just what I need, which is great. So now, again, starting these 4 classes, we need to put ogive. Again, main thing is make sure that it nicely fits. So if that's 31, the starting points, right? 42, now there's 53 and 64. Okay. And the story at 76. So now we're all ready to put those cumulative frequencies. That has 39 as the largest at the very, very end of the story. So it corresponds to the end of the sample and the height So it's always at the end. Now, at the end of my first class, I need to put cumulative frequency here, 16. Please notice it's less than a half, right? 16 is less than a half of 39, so a little bit less. So 16 twice is 32, so a little less than a half. Okay, next point. Now we have 30. 30, okay, about here. We get 30. Again, at the end of my next class, which is someplace here. And then 30E. Should be right in between of this. Ogive is coming. Connect them with points, with a straight line segments. Those little points connect with straight line segments and get the result. The graph of cumulative frequency distribution called ogive is done. Well, I think it's already good enough. Looks like people started to log out. I know it's getting a little bit too much, so I'm going to stop to record. I'm going to start to record and stop to record and see if you have any questions. If you have any questions, please ask. Don't hesitate.